Go ahead.
Yeah, okay. So I'm Janardhan here. I'm currently working as a machine learning engineer at some XYZ organization. So I'm here today to give a presentation about just an overview about what is machine learning and where it is used currently in a present technology. So I'll just quickly share my slides. Oh, 1 minute. I'll just. So basically, in just talking from the PPT, I just want to give a what is generally the machine learning. So basically, before we go in depth about machine learning, we first need to understand what is that machine learning. All we are talking about, and it is booming in the present technology. Something. So machine learning is not nothing about. We are just teaching the machine. So we already know like that machine, a system or a server, it is not having the intelligence. As a human, we have the intelligence. It is only good at storing and processing, where a human is lacks in storing a bulk amount of data or processing in a quick manner, or the machine can do. But machine is like a stupid machine. It does not know anything how to behave or nothing. So we program them, like we say the instructions, by giving the instructions or writing an algorithm, it is actually behaving however we want it. But it is good at processing and storing the things. So the field of study that gives computer the ability to learn from the data without being explicitly programmed. So basically, for example, I just want to compare between the say Python programming and the machine learning. See, in Python programming, for example, if you want to write finding a factorial of a given number, you just write 3 or 4 lines of code. The logic you'll be writing, it may be in any programming, like only the syntax changes, the logic remains the same. But in machine learning, you cannot have like so many if else conditions. And say, for example, it is very difficult, right? Like writing so many if else conditions with so many features. So what we do, it's a data driven thing. Basically, machine learning understands the past data. See, it is not the thing which is without seeing something or without learning anything, it is predicting or it is classifying something. It's not like that. It is being programmed with the data. It's basically data driven. It is understanding the past data, our behavior. So how the child also grows, it also learns from his parents. How we also grown, my mother taught me like this is fire, we should not touch it, so it will hurt us. So likewise, we also now we become a trained model. After a certain time, we become a trained model. We know which is good, which is bad, even though we try to attempt it like that. So machine learning is all about like that. It is also learns through the experience, and a product is built, an application or a model is built, then you can do the testing like that. For example, I just want to show the see, I just was talking about the traditional programming. A data is we write a program and we get the output. But whereas in machine learning, what we write, we build the ML algorithm, we deploy that model, and then we get the corresponding output. So, guys, this is a general overview of a machine learning architecture. For example, the first is the business understanding. For example, here people in this bridge might be working in different organizations where we'll be getting so many amount of data, right? You might be running some application where some logs will be generated every minute or every seconds. So we have to understand the business first of all and what we are working on. So if you want to apply machine learning on top of it, we have to understand the business. Okay, are we going to do a classification or are we going to do a prediction? So for that thing, first we have to understand the business. Okay, when I run a test, say let us just take an example. We are doing a regression. We are doing a testing. Whereas it will be a positive scenario, negative scenario. There might be some chances of network issue or environment issue. There is a validation or a script issue. Some kind of logs is being getting generated. Okay, so what we have to do, we have to take those logs. So we have to understand what these from these logs, what are the insights can we get it. Okay, with this data can we build a model. can we build a machine learning model or something? So we have to understand the business first of all. Okay, we understood the business. It's like a software development life cycle. We have to understand the business. So for those business, we have to collect the features in the sense, what are the inputs? For example, I just wanted to correlate with the real time example. For example, if you're going to a doctor, for say you have a fever, if you go and sit in front of a doctor, can doctor identify what is the problem you have? No. He will ask you what is the problem. By seeing you, he cannot identify whether you have a stomach ache or a fever, right? He cannot do that. So we will be telling, I've been having a fever. Then he do some history. So he'll ask how many days you have fever. Do you have any other symptoms like headache or stomach ache? So he will be observed. So he will correlate with the studies, and then he subscribe you the medicine. He give the prescription. Okay, take this medicine. So if you have fever for 1 day, he will say just go with a slow mild, and he'll give suggest one tablet. Else, if you're having a suffering from fever for the past 3 4 days, he may suggest you a blood test or something. So it's all about, they're not just coming on their own. They have seen many patients before us. So through their experience, they are coming to a conclusion. Okay, for these symptoms, we can suggest this. So likewise, machine also learns every day or every minute data. So the first is the business understanding. Once business understanding is done, that is the process. We come into next process called ETL, extract, transform, load. So we try to collect the data. Okay, we understood the business. For this business, in order to build a machine learning model, we have to collect the data. That is the process they call as ETL in machine learning. Extract, transform, load. So we collect the data. So maybe in your XYZ organization, the logs might be generated, say in some applications keep on generating the logs. We have to write a platform and collect the logs. Okay, that is the first thing. Once that is done, then comes a data acquisition and understanding. Okay, so we have to take that data. Okay, what is the logs that has been written? Okay, whether that logs is in integer format or in a string format. What are the insights when see machine learning is comes after that. We as a human, we need to first have the intelligence. From this data, what I can do, then only I can go and build a model or do whatever things I can do it. But before we do anything, we should have the intelligence. As I already told, machines does not have the intelligence. We should understand what is this input feature is telling us. Is this input feature is required, or we can throw this? Basically, this symptom telling to a doctor is prescribing the correct medicine, or this symptom is not at all required. So something like that, we have to take each input feature and we have to do a study on that, whether this feature is really required. So we have to get an understanding about the data. Once the understanding is done, that they called in machine learning term is called pre-processing, uh, otherwise called as exploratory data analysis, EDA. So we do some research on the data which we have collected it. So that is called exploratory data analysis. Are there any missing values, or in place of a integer value, or there is a string value, so how can we replace it? So, for example, we might have also felt that, for example, if you float a Google form, if we have not given the few columns as mandatory field, people tend to fail to fill that, right? So, in such cases, for in order to feed my data to a machine learning model, the data should be very clean in the sense there should be no missing values. So I have to take care of all those stuff before I build my machine learning model. So this process is called as EDA, exploratory data analysis. You do some research on the data which you have collected it. Post that, once your data is being cleaned, replaced all your missing values, then you go ahead with the modeling, which we'll be talking about feature engineering, model training, and model evaluation. So before we build a model, we have to do two things. One is feature engineering and feature selection. This feature selection is basically, for example, in order to say whether the person is having a diabetes or not. Say we are taking a case study called whether the person is having a diabetes or not. So in such cases, I have collected, say, about 30 features, whether the person is having a diabetes or not, symptoms, or for how long he's been suffering from diabetes, whether the person is taking continuously tablets, are there family by family, means the generation by generation, this is the patient is having a diabetes. So something data have been collected about each patient, maybe some 30 features, some 30 unique features I've collected about it. So first of all, I have to do a correlation study. So correlation is basically what I will do. In machine learning, we have two things. One is dependent variable and this is independent variables. So the independent variables, you can just remember independent means it's basically input features. By that features you are going to predict what is the basically the depend. For example, as I told, diabetes, right? So the person either can be diabetes or non-diabetes. So whether the person is having a diabetes or not, it is dependent upon the features. Means whether the person is by seeing his history, like what are the features we have collected. So we do for example, we can take for example, he's a diabetic, so we do for how long he's been having a diabetes. So we study the relationship between these two features, that is called correlation study. So in statistics, you might have discussed, we might have come across this positive correlation, negative correlation, and zero correlation. So when we study the correlation between two features, when it is great, and the correlation value is all, the range is from -1 to +1. So if it is less than -0.7 to -1, it is a good negative correlation. If it is 0.7 to +1, it is a positive correlation, and it is good to have that feature. And if it is a zero correlation, then there is no use in keeping or retaining that feature for our analysis. So we have to do through some statistics, we have to understand what are all the features which is required for our building our model. So this is called analysis phase, like a feature selection phase. Once that is done, we go ahead with building the model. So building the model, so how I should, which model should I choose? So so that is dependent upon the data you have it. So depending upon the use case or depending upon the data, we have to choose the right optimal model. See, in machine learning, the models are already available. We have to just hyper tune the parameters. See, there are two things. One is model parameters and optimal parameters. Optimal means hyper parameters. So model parameters means which is depending upon the data you provide. And there is an hyperparameter which is not depending upon the data you provide, which is fine tunes the overall algorithm. So once you build a model, then you go for a deployment phase. So before deploying, we have to do a thorough testing phase. So once you test your model with some related data, once your model is able to predict or classify correctly, then you deploy into the customer environment. Once customer as means customer is able to get the correct classification or prediction, then the model is stable. If there is some uncertainties, then we have to retrain the model again, then redeploy the model into the customer environment. So just to summarize this machine learning architecture, the first is the business understanding. Once that is done, the next is the ETL, extract, transform, and load. The next is the basic process called EDA, exploratory data analysis. Once that is done, we do the modeling. Basically, modeling has feature engineering, where we do feature selection. Then we come for the testing phase. Once you tested your model is behaving correctly, there are metrics in machine learning for each algorithm, how your model is behaving, how it is correctly classifying or not, how many values it's been correctly classified. So there are a few things. So on next we come into the deployment phase. Once it is deployed in the customer environment, we keep on checking the say the accuracy of your model, how it is behaving in the customer environment. So just to overview, like we have three types of machine learning things. One is supervised, unsupervised, and reinforcement learning. Just assume supervised is nothing but there's a teacher who is guiding the student. That is called supervised. We're all studying in a college, and there is a mentor for us who is teaching us. Unsupervised is basically I'm learning by myself. That is called unsupervised. Reinforcement, there is no data or labels which learns through a trial and error method. So let us first concentrate on these two things as of now, supervised and unsupervised. Supervised is basically I'm telling my machine if these are all my inputs and this is the corresponding output y. So I'm teaching my machine inputs as well as output. So for example, let us take another case study called house price prediction. Say this is a generic example. Say we have the square feet of a house and we want to just predict the price of the house. So we'll be teaching the machine if this is a square feet, this will be the price. Just assume that we have only two features as of now. As I was telling, in machine learning, we have independent feature and dependent feature. The independent feature is the square feet, and the dependent feature is the price of the house. So we are going to take the square feet of the house as an input, and the output is the price of the house. So we are going to teach the machine with say some thousand or 10,000 data points. Data points means likewise I've collected from different cities and I fed my machine. If this is a square feet, this might be the price. So my machine is learned. I did all my ETL, EDA, feature selection. Then I built my model. Then I tested my model and deploying it in the customer environment. So now my model is capable enough that it can, but any customer if they come with a square feet, they can know what is the price of the house, means the land price or something. See, this is just a small example. See, with the square feet alone, we cannot say what is the price of the house. At this the right moment, we have to check where the house is located. Is there any nearby schools? Is there nearby? But is my house nearby the bus stand or bus stop? So something. These are all the features also come into picture. A number of rooms in the house. So these are all the input features which we have to take into consideration. For example, there's a square feet is very less, but which is located very near to bus stop or school, the price will be large. The price will be high. But if the house is located too far, maybe in some interior village or interior place, the price will be less, even though the square feet is large. So my machine has to learn independent of it. See, in such things we cannot do in a traditional programming where we have to write if else for handling these many conditions will be very hectic. That's why we come up with a data driven approach where we feed our machine with a certain amount of data so that my machine can understand, okay, if these are all my input feature, this can be the output feature. So it will able to learn the uncertainties, like say in this case, which is where my house is very nearby to school or bus stop. So if this is the condition, the price is this, or if it is an interior place with a large square feet, this is the price. So I'm making the machine to understand. See, in machine learning, it is not always possible to get 100% accuracy or 100 percentage loss. See, so we have to try at least some 98 and 99 percentage. We have to get the accuracy or something. So we have to try for that. So in order to do that, we have to give an enormous amount of data for the machine to learn the in-depth intuition what we have the understanding. So see, like as a human, we also learned like English. Also, we started from the KG, then first standard, then we started with the letters, then words, then sentences, like that, no? So same wise the machine also can learn very quickly, but it needs a good amount of data because it has to understand the insights, what is there, what is that. So if we come under this supervised, we have two things. One is a regression thing and another is classification. Regression is basically uh, uh, in our output, if you want to predict some continuous value, that is called a regression. Basically, might be we have discussed about, we might have studied about this continuous variable and discrete variable. Continuous variable is maybe the weight of a person. We can have 65.5 kg or 73.2 kg. A discrete value is basically a number of students in a class or a number of members in our family. We cannot have 4.5 students in my class. So this is the example of continuous and discrete. Continuous is basically when we want to predict the continuous data, we go for a regression task, say house price prediction, okay, or what is the salary of a person given an experience. Okay, so these problems come under the regression problem or a time series data. I wanted to predict what might be the temperature around 12:30 today. So something, this is all related to some continuous data and comes under regression problem. The next we have the classification. So as the name indicates, we are going to classify what group it belongs to, whether the person is a diabetic or a non-diabetic. whether the given thing, whether the person is suffering from, whether he's a alcoholic or non-alcoholic. So might be we have also seen about this data set, which iris setosa, like this iris virginica. So something related to this, or given an image is a dog or cat in a image side, means in a deep learning side. So this comes under classification. In classification, we have binary classification and multi-class classification. Binary means where we have only two outcomes. Either it is diabetic or non-diabetic. Yes or no. True or false. So that is binary. Binary means it is true. So we are going to say either yes or no. Whether the person is diabetic or non-diabetic. Multi-class classification means we are having more than two categories. Say for example, given the features, whether the feature is say red color, green or blue. So these all the machine has learned already. So we are teaching the machine, if these are the features present, this belongs to cat. If these are the features present, this belongs to dog. So something we are teaching the machine already the features. So we already know that machine cannot understand strings. It can understand only the numbers. So in machine learning, we have the techniques like label encoding, one not encoder to convert your strings into numbers. When we go into NLP side, natural language processing, where the chatbots and AI like Chat GPT, how we are feeding an string, we are getting response also in the back of input strings, right? So how that is happening in, see, machine is not learning directly taking strings and processing. It is taking the strings and doing an embedding on top of it. So there are predefined embedding techniques which will convert your strings into vectors, say like TF, IDF, and BERT, which is being used by Google right now. Bidirectional encoder represent from transformer. So there are predefined embedding techniques are there which will convert your text to numbers. Then it do the processing, then you get an answer in the back of string, then I do the computations. There are many things involved, but we feed input, we get an output back. See, in everyday day-to-day daily activities, we ML and machine learning is been growing, but we are not observing. See, for example, in a YouTube, there is a good thing called recommendation thing. See, you just start watching about some actress video or some actor's video, something you get a recommendations about them soon. For example, in an Amazon website, if you try to purchase say some dress, so you get a recommendations about the dress similar to that or similar products. So that is all machine learning, or machine learning is revolving around it. So that is basically called the recommendation system, that comes under the unsupervised. So we have understood about the supervised regression and classification. Now we'll come into the unsupervised machine learning algorithm. So in unsupervised machine learning algorithm is nothing but, like for example, we are feeding only the inputs. For example, I've collected some amount of data, and I'm not sure. I want the machine to just classify into clusters, basically groups of data. Okay, so what it will do, I have collected some logs which is generated from my real time data which I'm in my organization. I don't have any insights. What I'm doing, I'm just giving that logs all to my machine learning. What my machine learning will do, my machine learning will analyze my data and it will put them into groups. So these all belongs into one group, these all belongs to second group. So we have to define the number of groups. So based on the number of groups, it will put based on the similarities. So it will see between two data, it will see what, okay, there are a few similarities between these data. So those data it will put in one group. 99th row and 76th row, okay, these are having some similarities. Okay, we put all this data into one group. So like that, it will observe the patterns, underlying patterns between the data and put them into different groups. So which I was telling, this is the data set for classification. So where you could see which I was telling in a machine learning term, the sepal length, width, petal length, and petal width. These are all called my independent features, and the class label is called my the dependent feature. So this dependent feature, why it called dependent feature? It is depending upon these input features in order to know what is this value. So this is setosa. Setosa has a features of this one. So in order to say this is iris setosa, this being depending upon these independent features. But these features are not dependent on any another. So I was telling about the correlation study. So whether should I keep my sepal length in my data set, or this feature is not contributing for predicting this iris etos or virginica or versicolor. So in order to do that, I do a study called correlation study. So what I will do in such cases, I will take this class label and the sepal length. I will find the I will find the correlation study. So I'll do a correlation. So I find my correlation value is something is closer to +1. I'll take it for my consideration. If it is less than -1, means the range is from -1 to +1. If it is greater than 7.7, I'll take it. If it is less than -0.7 to -1, I'll take it, because it is negatively telling. For example, a good example is house this ice cream sales. See, the ice cream sales in summer days it will be very high, but in a winter, in a rainy season, the selling of ice creams will be less. So that is one is positively correlated. If the temperature is increasing, the selling of ice cream is also increasing. The other way, if the temperature goes down, the selling of ice creams also goes down. So this, the increasing way is basically called the positive correlation. The decreasing way is called the negative correlation. So with the correlation, we can understand how much sales we can do it. In an unsupervised learning, for example, there is a called as association rule mining. So what they do for customers in a say, we take a real time example of department store. So what they do, they keep bread and butter together. So they study, they analyze the customers who are coming to buy. So they, for example, there is a customer one came to a shop and he purchased, say, some 10 items. He did that is called a transaction. In the that transactions, he has purchased 10 items. So likewise, customer 2 will come, he will do some transaction, say he has bought some 15 items. So what this ML engineers do, they try to understand what are the items they bought together. For example, customer 1 came, he brought bread, but also he brought butter. So likewise, he brought bread. The other customer bought jam also together. So they try to study the associations between what are the items are purchased together. So likewise, they will come to learn the customer's mindset. Okay, people coming to buy this item, so they are tending to buy this item also. So what they will do, the retailer will try to keep bread and jam together, so that even though I have jam at my home, I'll try to, okay, it's fine, we can take one more jam, what is the wrong. So we are increasing the business. So this is the where this is a common example where real time we also like assume that, okay, they have arranged this. Say they are understanding the customers mindset, and they are increasing their business. So this is the analysis we have to do on the data. So, where this data scientist, data analyst, and machine learning engineer will do the analysis about the data. It's not about that machine learning is about building a model, deploying the thing. It is all about understanding the data. So see, for a machine learning engineer, data is very much important. If the data is not good in shape, then there is no point in building a model or deploying a model. See, he can work today in a telecom industry, tomorrow he can go for a e-commerce industry. He cannot learn how building a model or something. He has to understand the data. Okay, being in a telecom industry, with this data, what can I do? Building a model, testing it, deploying it, it's all a common process. As an ML engineer or a data engineer, he should understand what is this data. With this data, can we build a model? Okay, with this data will really be an impact for prediction. So something, this insightful information can be derived. That is more important rather than building or deploying or something. That will come automatically. We have a predefined algorithms for everything. For example, if we take supervised machine learning algorithms, say we have linear regression for continuous variable, means for regression, and logistic regression, SVM, KNN, random forest, decision tree. These are all for classification task. And then for unsupervised, we have K-means, DB scan, and hierarchical clustering. And going forward, we have deep neural networks, where we have artificial neural network, current neural network for processing the text, which we are using this chatbots and all today, and CNN, convolution neural network uh, for dealing with images. For example, a person is walking on the road, whether he's female or a male, or when the or there is a sensor has been attached to the door of the entry, so it just recognizes the face and just opens the door. So everywhere this AI has been taking place, but we are not aware of that AI has been but AI and ML is everywhere, but we are not noting down that. And NLP is a natural language processing, which is very good at for strings based, how to say given an email whether it's a spam or not spam. So we have to do string based handling there. Because everything will be in a strings, we have to handle for example, a good example is if there is a hot news is being happened, and there will be tweets, people will be keep on posting the tweets, so we have to take their tweets from the Twitter, and we do sentiment analysis. Are they talking about positively or negatively, or people are neutral about it? So this AI, ML, and deep learning has been revolving the world now. Yeah, sorry, 1 minute. Yeah, anybody having like any doubts or something?
No, sir.
We are able to get it like correlate things with the real time use case, how something.
Yeah, everyone is finding the speed is good. Anything like you can speak, right? Because you are hearing last 20 minutes, right? So what you are feeling, right? Are you feeling comfortable, not comfortable, right? Any question, any doubt, you can ask to him, right? Or is it everyone is fine? So right, this speed is fine, right? Because you have to give the feedback, right? Because someone is speaking, so he will come to know about your feedback, then he can follow that way. It's fine, everyone? Good. Okay, I think everyone is good. Yeah. Mm.
Yeah, like let it be like we'll wrap here like with the intro, I feel.
Yeah, well, just some Expedia one, something you can tell for next
Yeah, yeah,
week, they can prepare it. And
yeah,
you
sure.
can give the basic part of the Expedia, like what is the case study we are going to cover in next weekend.
Yeah,
So
sure.
the people can do study also, right? I will share the other material. Okay, so but meanwhile, you give the basic idea about that. Yeah, so
Yeah,
that,
sure, sure.
okay.
Yeah, sure. Yeah, sure.
Okay.
Right away. Where is that? Okay. For example, I have taken hope my Google Collab is visible to you guys. So right now I've taken a real-time use case of Expedia hotel recommendation. So you might have heard about this Expedia website, like where it's a global travel website where you can book your flight, hotel, or whatever it is. So so what they have given the customer data, like it's consist of hotel continent, where they are from, market, and they've clustered the, means they have grouped the data into different clusters, say some 90 or 91 clusters they have clubbed. Okay, if these are all the features, if the customer is coming with these timing, or if they are from this country, and some they have given me some input data, means the input features. So based on that features, they have classified these people will opt this hotel. Having this mindset of people is opting this hotel. So they have given this amount of data. See, I have some around 3.7 billions of sorry, not billions, millions of records, means rows of data. I've taken a data for my analysis from the Expedia. So it is available in Kaggle website. The data set is available there, so you can also download it and you can explore. So the first thing is we have to explore what are the features are there. The first thing we have to we have to explore like this. Say for example, there were around some 24 features, from date, time, site name, Like this, there are some 24 features. So after taking these features, first of all, we are so it is all about like ETL. We got the data. Next, the thing is we have to do the pre-processing. So in the pre-processing EDA process, we have to do some study, the correlation study, whether this feature is important, feature selection. So see, hotel cluster. So idea of the means this is the independent sorry, dependent variable of my data set. So they based on these all features, they have clubbed these hotel into some groups. People are having this mindset, are taking this hotel. See that clusters they have defined, right? 0 to 91 hotels. Maybe that 0 is a 5-star hotel, is a high class hotel. 2 is some 2-star. So something they have designated that 91 hotels with some based on some unique features. So what I can do, I can build a model with this. So I'll do my ETL. ETL is done. Next, I do EDA process. So these are all the phases I have to do. For example, exploratory data analysis. I have to do in exploratory data analysis. Days stored by the days stayed by the customer. How many days they have stayed? Are there any NAN? Which not an NAN means not a number. And outliers is basically a quite example is, for example, say I'm working in some XYZ organization. I'm a fresher, I've joined. I'm planning to find the average salary of an organization. See, the intern salary might be in some thousands, say in thousands, and say some 25K or something. The CEO salary might be in some lakhs, say some 60 lakhs per month, or some say some 50 lakhs per month. So if I try to find the average salary of an organization with including intern salary and CEO salary, the average will not be a good fit, because there will be too much deviation. If I'm a fresher, I cannot say my salary itself is say some 25K, but the average is coming around some 1.5 lakhs or 2 lakhs. So that is not too much deviation when corresponding to the average on my salary. So it's in a real time, I can just say the intern salary and the CEO salary and the freshers, or one say with less than 2 years and greater than 25 years or CEO, they are all considered as an outliers, which is actually manipulating or deviating the average. So okay, in that case, how should I find the average salary of an organization? So we can see, when we are having an outliers in our data set, going see, we might have already studied about the statistics, mean, median, mode. Mode is for categorical data. When we have say in a what to say, in a tub we have a color balls. We have to find which is the color which is which which color of ball is there more. So that is if there is a red, blue, green, red color balls is more in number, means we say that is the mode, right? But mean and median we might have studied in statistics, but we must also know in what place we have to use mean and in what terms we have to use median. See, when we have outliers in a data set, it is always good recommendation to go with median. But we might have studied in school math, just go with mean, median, but we have to understand. So this is where our real things comes into picture. So in mathematics we just study taking numbers and we solve it. But now with the machine learning we'll able to correlate the statistics, why median is required in this place, or median is required, or median is or mean is required. If there are an outliers, we have to go with the median as the best option. So we have to do outlier study. Then the correlations, which I've discussed already, are checking for duplicate values. If there are duplicate entries, what I can do, I can actually remove those entries from my data set, and I can go ahead. These are all coming under my pre-processing steps. Then the imputation. Imputation is basically replacing a missing values with something. Then further EDA and visualization. So we do kind of visualization. Okay, uh, how many say in a gender column, male and female, how many male are there, how many female are there. So through visualization we get a very good attention, like so we can also understand very easily. So then accuracy calculation, then building a model. So building a model, we have to choose the right optimal model for for our data. That also we have to do some study. Each algorithm, say these are all the algorithm which I told, random forest, naive bias, logistic, KNN, XGBoost, decision tree. So each algorithm has its own advantages, disadvantages, and some algorithms good at handling input in the forms of number, floats, and the dimensionality, the number of rows and columns. So every algorithm has its own advantages and disadvantages. So we have to choose the optimal model for our own data. Then comes the testing phase and the deployment phase. So we will be discussing with the coding part in the next workshop. It's actually ready. We can see it in the next demo how we are doing the real ETL, EDA, then how we are imputing the data, then how we are building the model, and how we are testing the accuracy. Everything we can see in the next workshop. You can also, in meantime, you can also explore about this. Yeah. If there are any questions, I'm ready to take up. Even if it is a very basic doubt, I can answer you. Or any suggestions or something. Feel free to share it.
Yeah, thank you for your demo. I really loved it. One thing I wanted to understand, so is that going to be a complete training, or are you going to just to conduct only the workshop? From here, how we need to proceed further? And the second question, do you suggest any books or blogs to learn basics of machine learning and further into the AI side?
Yeah. Arvind sir, like,
Yeah.
can you?
Yeah. Okay. So your first question is like, okay, he has planned, actually, he's preparing a one complete classroom things, okay, but he wants to give first demos, right? Okay, like you guys understand him and he can understand like how many people, audience are coming, they are really interested because machine learning data science is a unique field, right? Because it's a top of the data engineering. And if like people have more keen interest and they want to go in this particular direction, then it is useful, otherwise it will be not useful. Okay, so first let I'm planning it like, okay, some use cases things he should show at least 1 or 2 weeks, right? Next week or next to next week. Then once the people understand really these are the good use cases and more learning things, then he will plan a one short course, right? Crash course, right? Which is just like you can even along with other fields also you can show, right? Even you are in analyst, data engineering, you can along with that you can utilize. Okay, so that he has planned and he will show next week that course plan agenda. Okay, but we first he has planned for the two case studies. Okay, I have given him the those case studies and he will show the proper demo on that, like how end-to-end flow and like one is the Expedia he was talking about. Okay, I will share the PPT presentation of that. Okay, what are the things you will get in that learning, right, in the next week, so that you can prepare also your analysis and facts, so that it will be useful, right? Okay, so I want him to like explore and interact to you guys, right? Because I'm giving a chance to him because he's he wanted to share his knowledge skills, right, to everyone. And people come forward first with the interactive session, right, and they are really getting knowledge and they can give a proper feedback to him, right? So then it will be good for him to like next further go. Okay, and you were asking second thing, what you were asking?
Since we are starting from beginning, we would like to know
Okay, book,
if he's
right,
going to suggest any books
material, right,
or any
okay.
blogs or material, anything to
Okay,
start with
I'm already
information.
posting in my group. Okay, and you can ping me. I have a lot of books materials also there. Okay, I will share because some of the times, like I find people are different background people are there, right? But still, I try to provide more and more like e-books and whatever the machine learning, generative AI is, right? This is trending things going in the market, right? So if you are starting little bit on these things, so it will be helpful for learning, right, further, right? So I will post more things, okay? and which is related to these stuff, so that it will be helpful for further learning, right? But I will say, rather than going through books, all these, the best learning is a practical, right? You like see the things and do practical hands-on, then you will realize, right, are you really on the track or not, right? Okay, books are fine, because with the first learning is the books only, right? But second learning through hands-on practical, right? Okay.
Sure. Great. Thank
Okay,
you.
thanks everyone. I will share this recording. Like basic fundamentals is very necessary, right? Because sometimes we know, right, machine learning algorithm, but how many types are there? What are the each one, right? So what are the types of further like classification or clustering? So we should know each and everything. Okay. Okay, thanks everyone. Thank you for participation. Thank you.
Yeah, thank you
Thank you.
guys.